Cosmic voids, an introduction to black holes. Black holes are one of the most mysterious and fascinating phenomena in the universe. They captivate the imagination of scientists and enthusiasts alike. Black holes are fascinating objects in space. They are regions where gravity is unbelievably strong, so strong that nothing, not even light, can escape their pull. This makes them invisible to the naked eye, but their presence can be inferred by their effect on nearby matter and light. They are regions where gravity is unbelievably strong. Imagine a place where the gravitational pull is so intense that it warps the very fabric of space and time. This warping effect can be observed through phenomena such as gravitational lensing, where light from distant stars is bent around the black hole, creating a distorted image. Imagine a place where even light, the fastest thing in the universe, cannot escape. That's a black hole. The boundary around a black hole, known as the event horizon, marks the point of no return. Once anything crosses this boundary, it is inevitably pulled into the black hole, never to escape. Black holes are born from dying stars. When massive stars exhaust their nuclear fuel, they undergo a dramatic transformation. The outer layers of the star are expelled in a supernova explosion, while the core collapses under its own gravity. When massive stars run out of fuel, they collapse under their own gravity. This collapse is so powerful that it compresses the core to a point of infinite density, known as a singularity. The singularity is surrounded by the event horizon, beyond which nothing can escape. This collapse creates a point of infinite density called a singularity. The singularity is a place where the laws of physics as we know them break down. It is a region of infinite curvature, where space and time become infinitely distorted. Black holes don't suck in everything around them. Contrary to popular belief, black holes do not act like cosmic vacuum cleaners. They only affect objects that come very close to them. For objects at a safe distance, the gravitational pull of a black hole is no different from that of any other massive object. They have an invisible boundary called the event horizon. The event horizon is the defining feature of a black hole. It is the point beyond which nothing can escape the gravitational pull of the black hole. The size of the event horizon depends on the mass of the black hole. If you cross the event horizon, there's no turning back. You're trapped forever. Anything that crosses the event horizon is doomed to be pulled into the singularity, where it will be crushed to infinite density. Scientists study black holes by observing their effects on nearby stars and gas. By tracking the motion of stars and gas clouds, astronomers can infer the presence of a black hole and estimate its mass. Even though we can't see them directly, we know they're out there, shaping the cosmos with their immense gravity. Black holes play a crucial role in the evolution of galaxies and the formation of cosmic structures. Their immense gravitational pull can influence the orbits of stars, trigger the formation of new stars, and even affect the distribution of matter in the universe. Bridges through space and time. The concept of wormholes. Could black holes be more than just cosmic traps? Some scientists believe they might be portals to other universes. These portals are called wormholes. Imagine folding a piece of paper in half. Now imagine a tiny tunnel connecting the two sides. That's a simple way to think about a wormhole. It creates a shortcut through space-time. Wormholes are theoretical objects. We haven't observed them directly, but Einstein's theory of general relativity suggests they could exist. If wormholes exist, they could connect distant parts of our universe or even lead to other universes entirely. It's a mind-boggling possibility. The point of no return. Event, horizons and singularities. These are two of the most fascinating and mysterious aspects of black holes. To understand black hole portals, we need to talk about event horizons and singularities. These concepts are crucial in the study of black holes and the nature of our universe. The event horizon is the point of no return around a black hole. It is an invisible boundary that marks the limits of the black hole's gravitational pull. Once you cross the event horizon, gravity is so strong that nothing, not even light, can escape. This is why black holes appear black. They trap all light within this boundary. You'd be pulled towards the singularity at the center. The singularity is a point where the gravitational forces compress matter to an infinitely small space. The singularity is a point of infinite density. This means that all the mass of the black hole is concentrated into a single point with no volume. It's where all the matter in a black hole is compressed into an infinitely small space. The laws of physics as we know them cannot describe the conditions at the singularity, What happens at the singularity is a mystery. Scientists are still trying to understand the true nature of this phenomenon. Our current understanding of physics breaks down at this point. The equations that describe gravity and quantum mechanics no longer apply. Some scientists believe the singularity could be a gateway to another universe. This idea, while speculative, opens up exciting possibilities for the future of space exploration and our understanding of the cosmos. If true, black holes could be more than just cosmic vacuum cleaners. They might be portals to entirely different realms of existence. This concept challenges our perception of reality and invites us to explore the unknown. As we continue to study black holes, we may one day unlock the secrets of the event horizon and the singularity, leading to groundbreaking discoveries about the universe and our place within it. A journey through the looking glass, entering a black hole. Imagine falling into a black hole. What would you experience? It's a question that has captivated scientists and science fiction writers alike. As you approach the black hole, you'd feel its immense gravity stretching your body. This stretching effect is called spaghettification. If you were facing the black hole, your head would be pulled more strongly than your feet. You'd be stretched like spaghetti. Time would also behave strangely. As you fall towards the event horizon, time would slow down for you relative to someone watching from a safe distance. Section 5. The ultimate cosmic reversal. White holes and emerging universes. If black holes are entrances, could there be exits too? Some theories suggest the existence of white holes. While nothing can escape a black hole, nothing can enter a white hole. It's the opposite of a black hole. Imagine a fountain spraying water. The water flows out but never in. That's similar to how a white hole might work. Some scientists believe that a white hole could be the other end of a black hole. Matter and energy falling into a black hole might emerge from a white hole in another universe. Section 6. The perils of the journey. Spaghettification and Hawking radiation. While the idea of black hole portals is intriguing, there are significant challenges to overcome. One challenge is the extreme forces near a black hole. Spaghettification, as we discussed earlier, would stretch any object falling into a black hole into thin strands. It's not a pleasant way to travel. Another challenge is Hawking radiation. Stephen Hawking proposed that black holes aren't completely black. They emit a faint radiation due to quantum effects. This radiation would eventually cause a black hole to evaporate, although this process would take an incredibly long time. It's unclear if a portal could remain stable with Hawking radiation present. Section 7. Elusive evidence. The challenges of observing black hole portals. The biggest challenge to the black hole portal hypothesis is the lack of observational evidence. We haven't found any definitive proof that wormholes or white holes exist. Observing black holes is already incredibly difficult due to their extreme gravity. Detecting a portal within a black hole would be even more challenging. However, scientists are developing new telescopes and techniques to study black holes in greater detail. Perhaps one day, we'll have the tools to confirm or refute the existence of black hole portals. Section 8. Black holes on the silver screen. Popular culture's take on cosmic portals. The idea of black holes as portals has captured the imagination of filmmakers and science fiction writers for decades. The movie Interstellar features a visually stunning depiction of a black hole and a wormhole that allows astronauts to travel to a distant galaxy. While Interstellar took some creative liberties, it was based on scientific concepts and consulted with physicist Kip Thorne for accuracy. Popular culture often portrays black hole portals as shortcuts for space travel, or gateways to other dimensions. While these ideas are speculative, they spark our curiosity about the cosmos. Section 9. A universe of possibilities, implications of black hole portals. If black holes are indeed portals to other universes, the implications are profound. Imagine a gateway that could transport us to realms beyond our wildest dreams, where the very fabric of reality might be different from what we know. It would mean our universe is just one of many, perhaps part of a vast multiverse. This multiverse could be teeming with countless other universes, each with its own unique properties and characteristics. These other universes could have different laws of physics, leading to phenomena that are completely alien to us. Imagine a universe where gravity works differently, or where time flows in a non-linear fashion. Different forms of matter and energy could exist, perhaps even forms that we cannot currently comprehend. Exotic matter, dark energy, and other unknown substances might be commonplace in these alternate realities, and even different dimensions of space and time could be present, offering a completely new perspective on the nature of existence. Higher dimensions might reveal new ways of interacting with the universe, beyond our current three-dimensional understanding. The concept of black hole portals pushes the boundaries of our understanding of the cosmos. It challenges us to think beyond the conventional and to explore the unknown with an open mind. It's a reminder that the universe is full of mysteries waiting to be uncovered. Each discovery we make opens up new questions and possibilities, driving our quest for knowledge ever forward. While we may never know for sure if black holes are portals, the very idea sparks the imagination. It encourages scientists and dreamers alike to ponder the vastness of space and the potential for otherworldly adventures. The possibility alone is enough to inspire awe and wonder about the vastness and strangeness of the universe we inhabit. It reminds us that there is so much more to learn and discover, and that the journey of exploration is never truly over.